All right, so let's go through this after I get through her. So what do we remember about this? Anything? Let's start with setting up finding A, B, and C first. Which piece is A, which piece is B, which piece is C? C is probably the easiest to spot. Because what we're doing is we're looking at our standard form up here. Just not the pen I wanted. Our ax squared plus bx plus c. So first things first, I want to know what A, B, and C are. A is, B is, C is. C is probably the easiest to spot. What's C? 8. What's B? Careful, because the B is in front of the x here, so it's just the -6. What number is in front of the piece? So what number is in front of the x squared? 1. When we talk about A, B, and C, that's what we mean. We mean those numbers. Just like if I was to put them in the quadratic formula. We're just looking at the numbers, A, B, and C. Turn the music off. I can hear the beat up here. This direction in general. The music is on and I can hear it up here. Turn it off. So the reason we care and the reason we want that is A, B, and C we're going to use to do our factoring stuff. There are a gazillion different ways of factoring. There's X in box, which is what I tend to use here. There's split the middle. There's factoring by grouping. There's a bottoms up. There's like a bunch of different ways. So if X in box is not the way that you do it, that's fine. Do what you need to do. You should wind up with all of the same pieces. X in box is just a visually organized way to do it. It's called an area model. But you should wind up with the exact same pieces. So if your pieces are lined up in a row versus stacked in a box, I don't care. You're getting the same answer. It's all good. Okay? I just tend to use X in box because it's visually easy to find all those same pieces, I think. But you do what works for your brain. So what we do is in our X frame here, we take our A times C at the top and we put our B value at the bottom. So our A is 1, our C is 8. 1 times 8 is 8. We put the B value at the bottom, -6. Now we find, this is kind of the mathy part, we found a pair of numbers that multiplies to be 8 and adds to be -6. What's a pair of numbers that multiplies to be 8 and adds to be -6? 4 and 2 agree will multiply to be 8 and add to be 6, but what did we forget? Negative. Is it just the -2? Negative on both. If the top number is positive, it means your sign is the same. If the top number is negative, it means you're going to have one of each. Okay, so it's an easy way to check that. Top number is positive, means they both match. After that, we're going to fill in our box with pieces from our equation. So from the equation, we get our x squared. From our equation, we get our 8. The whole point of this x frame is it takes this middle piece here and cuts it into 2 pieces to go into my box. So this is really -4x and -2x, because if I pulled that back out of the box, combined our like terms, we'd wind up with our -6. That's the point of the x frame. If you wound up with splitting the middle, you would get those same exact pieces. Factoring by grouping, you'd get those exact same pieces. Bottoms up is a whole different way of doing it, but you wind up with the same factors. So I genuinely do not remember how that one goes, but it's a thing. From here, what we do is we're pulling our common factors. We're looking for greatest common factors in columns and rows. What is the greatest common factor between x squared and -4x? What is shared between these 2 pieces? Just an x. What is shared between these 2 pieces? -2x and 8. I can't take a 4 out of 2 without giving myself a fraction. 2. But I will always, always, always match the sign of this box right here. So we're actually going to take out a -2. That spot will always have the same sign as that box, and this spot will always have the same sign as this box. Every single time. So then we need to do our rows. What's shared between x squared and minus 2x? What's going to be our common factor here? X. What is our common factor here? -4. And what this does is this gives us our factored form. We have our x minus 4 and x minus 2. So now we're going to start taking our forms and switching them. So we took our standard form and we put it into factored form. Those two pieces mean the same thing. They would have the same graph. Like in those Domino's cards, there's our top line and our middle line. Questions on that one, because it has been a hot minute since we factored, and it's okay if we forgot stuff. I want to answer your questions. Okie dokie, we're going to try it a couple more times. Same dealio here. Number 2. We're going to put our A times C at the top and our B at the bottom. A times C. What's my A value? 1. What's my C value? What's C? 16. A times C, so 1 times 16 is 16. What's my B? What's going to go at the bottom here? 8. I will almost always put the A times C and the B up there just because it helps me remember. I also almost always put I need something that multiplies to the top and adds to the bottom there because it helps me remember. Those are just tools for you to use. You don't have to use them. Same thing with the X frame, but they're just tools. What is a pair of numbers that multiplies to make 16 and adds to make 8? Yes, dear. 4 and 4. Yep. So filling in our box, we get our x squared from our equation. Honestly, this is where the most mistakes happen, is I'm getting this x squared from here. This 16 is this one. The only thing we use the x frame for is how this middle guy splits into 4x and 4x. The other two pieces come from the equation. The only thing coming out of the x frame are these guys. The only pieces. That is the biggest mistake I see on factoring, is we either don't check for a greatest common factor, which these ones don't because they don't have an A value, or we put the wrong pieces in the box. So pulling our factors here, what do we get? What's in common between x squared and 4x? First column here. What's shared between these two? X. Just an x. How about between 4x and 16? 4. Top row, x squared and 4x. X. And bottom row, what's shared here? 4x and 16? 4. Well, that sounded vaguely familiar. What operation is going to go in the middle on these factors here? Plus. Just checking because we didn't actually have to specify because there were minuses on both the first ones. Yeah. So we can write this as x plus 4 and x plus 4. What's another way I could write that? Yes. Because x plus 4 is being times by itself. So I could write this as x plus 4 squared. Those two pieces mean the same thing. So we went from standard form to factored form and kind of accidentally ourselves into vertex form right there because it happened to be a perfect square. Because this one is a perfect square trinomial is what that's called. It's got a special name. Since my factors are the exact same thing as a perfect square. Questions on this one? Okie dokie. Number 3 is a weird one. It's got a special name. It's a special pattern. If we don't remember the special pattern, it's 100% okay to keep on trucking and do the exact same thing we just did. X and box it, 100% works. But does anyone remember the name of this special pattern here? This guy is special. It's a perfect square. There's a special word in there that I need to. So something about perfect squares. What's happening between my perfect squares? That's totally meant to be a Q. What's happening between the perfect squares? We're taking a difference. It's a difference of perfect squares. Difference of squares. And that means if we remember the special pattern, we get to take shortcuts. We love a shortcut. If we don't remember the special pattern, that's okay. 100% still works to X and box it. The thing I'm going to ask us is this piece A, B, or C? A. Is this piece A, B, or C? C. What's our B? 0. So our B that goes on the bottom is going to be 0. Our top, A, and A is 1, C is -4, so A times C is -4. So then what we're going to think about, I need a pair of numbers that multiplies to be -4 and adds to be 0. -2, +2. It's kind of step 2 to fill in the box. Or to fill in that X frame. Yeah, it's just, the page just slowly stops giving you pieces. So you're going to have to draw your own pieces in it. Thank you, sir. The handout, you want to get that. Okay, so yeah, it's just slowly making you write more and more of the pieces. Whenever you have a 0 on the bottom, these two pieces will be the exact same number. One positive, one negative. So then if you want to do it in the box, it's 100% cool. We take our A term, our x squared, our C term, that -4. And what this is doing is this is uncombining our like terms. And we're going to pull our factors. What's shared between x squared and 2x? What would be my common factor here? X. Second column, -2x and -4. -2, good catch on that negative sign. Boom, shakalaka. Top row, x squared -2x. Just an x. And my bottom row, 2x and -4. 2. So our factored form here is going to be x plus 2, x minus 2. It's a special pattern called difference of squares. If you remember your special pattern, you can go directly from here down to your factored form, skipping the x in the box. But I also understand it's been about a year since we factored things, and that's okay. Like, no joke, a year, because in Algebra 2, we're doing it today, so I'm doing literally the same page of notes in every single class today. Yay. So much fun. But that's okay. It happens. So I want you to look at number 4. I want you to try number 4, because while you do it, I'm going to hand out another thing. just didn't have space on my table. Okay, so try number 4. I want you to see what you can do. What do we remember? Because slight refresher on the old factoring. Try number 4. I want to see what you get. All right. Let's fill in our X frame. What's going at the top? What's going to go up here? -3. What's going at the bottom? 2. So what pair of numbers did we come up with that multiplies being -3 and has to be +2? -1 and +3. I'm going to jump over the box. Hopefully we can start to get that kind of filled in. What did we get for our factors? And x minus 1. As we go through more and more factoring things, we're going to start to notice some little shortcuts. If we have an a value of 1, those are our guys. The -1 and the +3, x minus 1, x plus 3. Only works if the a value is 1. Only works if your a value is 1. If your a value is anything but 1, you're putting it in the box. I still put it in the box. Okay. So what we're going to do here is I want you guys to practice your factoring. For the rest of this time, there is an around the room activity. Yay, problem child. Which I have no idea if I actually put a thing up there. I did not. That's okay. So I give you guys paper. It's going to lead you from one problem to the other. So you start wherever, and you're going to do what it says. So like this one says factor completely. I'm going to factor the whole thing, and it says go to 8. So I'll do problem 1, and then maybe go to problem 8, and then maybe to problem 3, and then maybe to problem 7, or whatever. And it's going to lead you around. You should hit all 10 problems. There are 10. I am going to, don't rush through this. I'm going to leave this up for a couple of days. Like I said, I'm literally doing this with every class of mine today. So I'm going to leave this up for a couple of days because I'd rather you guys have the practice factoring than rush through it. So start wherever you want. Work together if you want to. I don't care. Just practice factoring. Because, honestly, it's one of those things that we use in algebra 1, we use in algebra 2, and it tends to be the first thing we forget as soon as we're done with algebra. So, go. Factor, do the thing. Huzzah. Please make sure before you turn it in, which will be for points, that you put the period number on it. Because like I said, I'm quite literally doing with six class periods today. So please put your name and period number on it. And then we're going to kick out a little music because it's a lot of knots today. But you can start wherever you want. You do not have to start with 1. Should be moving. do have a couple of clipboards if anyone would like to borrow a clipboard. I don't have many, but I do a couple of them.
Wait, do we have to start at this specific?
Nope, start where it'll lead you to all of them. And I'm here to answer questions. Y'all got questions? Happy to help. All that jazz. What are we doing today?
How was your weekend?
Good, how about you?
It was nice.
Okay.
stuff